Now, having been able to prove that the base angles of an isosceles triangle are equal, we are going into examples. Now, this is the first example we are looking into. An isosceles triangle is such that the vertical angle is 4 times the size of the base angle. What is the size of the base angle? Now, for this solution, we are going to have a picture to help us understand what this question is saying. An isosceles triangle. So we are going to draw any isosceles triangle. Okay, so these are the two equal sides. An isosceles triangle is such that the vertical angle, so this is the vertical angle, is 4 times the size of the base angle. So if the base angle is, say, x degrees, that means the vertical angle is 4x degrees. Is that okay now? We know the base angles, so this is also x degrees because they are the base angles. Okay, what is the size of the base angle? This is a very easy thing to solve because by so doing, provided we could get this diagram, we could understand from this question that this is the diagram we have. Forget the proportions, of course, I know. This should have been a flatter triangle, but we just have our isosceles triangle and then we have the vertical triangle being 4 times the size of the base angle. So what's the size of the base angle? Now what we are going to do is to say we know the sum of angles in a triangle are all equal to 180 degrees. So 4x plus x plus x are all equal to 180 degrees. And what's our reason again? Sum of angles in a triangle. Sum of angles a triangle. That's our reason. Okay, having had that, we collect like terms. We have that this is 6x is equal to 180 degrees. Now we divide both sides by 6, and then we have that x is equal to 180 divided by 6 is 30 degrees. So we know that the size of the base angle is 30 degrees. Very easy. Now we go over to the next example. In this next example, we've been given that triangle XYZ, triangle XYZ is equilateral. So we know equilateral triangles, all the sides are equal. And we've been asked to calculate angle NMX. That is NMX. So this angle, this is what we've been asked to calculate. Okay, so let's start off. So this is equilateral triangle. Triangle XYZ is an equilateral triangle, meaning that all these sides are 60 degrees. Let me use a pencil to fill that up so it doesn't mess up with the original diagram. So this is 60 degrees because this is an equilateral triangle. This is also 60 degrees. And after all this being 60 degrees, we know that from the proof of the base angles of an isosceles triangle are equal, we could be able to detect that the bisector of the vertical angle meets the base at, that is bisects the base and then meets it at, is perpendicular, that is the bisector is perpendicular to the base. So now, seeing that this particular line that comes from this vertex of the triangle is meeting this side at angle 90 degrees, that means that this is a bisector of this angle. Therefore, this is 30 degrees and this is 30 degrees because this line meets this base, this particular side of the triangle at 90 degrees. Therefore, it bisected this angle over here. Okay, So remember, we write reasons for everything we say. So let's get over that. So since XYZ is equilateral, we will say that angle XYZ, that's this angle. So solution, we have that angle XYZ. Let me also have that in the same line, is equal to 60 degrees, and angle XZY or YZX, whichever way. I'll say XZ and then Y is equal to 60 degrees. And the reason are equilateral angles in an equilateral triangle. Angles in equilateral triangle for short. Okay, having that aside, then we have that angle YXM is equal to 30 and angle MXZ, or whichever way you name it, is equal to 30 because of their bisected angles. Okay, having seen that, let's look at just this is angle 90, this is angle 90. And if this is angle 90, therefore this is angle 60. So all we just needed to do is that we are looking into this triangle that contains this angle we are interested in, angle NMX. So if this is 30, this is 90, therefore this is 60 degrees. But let's build that up. We have that angle, okay, I'm interested in just this angle, angle XMN. So we have that XMN is equal to 30 degrees. Okay, the reason for saying this being that this line XM, line XM is perpendicular to line YZ. So being perpendicular, that means it bisected the angle it has. So having this, we have, therefore, in this angle, in triangle, therefore, we have that 30 degrees plus angle X, M, NMX, NMX, as given to us in the question, NMX plus 90 degrees are all equal to 180 degrees, and our reason is sum of angles in a triangle. Okay, so that we have that angle NMX is equal to 180 minus 90 minus 30, and we have it to be 60 degrees. So we've calculated the angle NMX. Okay, let's look at this other example. We've been given this triangle ABD, which have been divided into two. So we have two triangles that we are looking at, this part and this part. And we've been asked to prove that angle X is equal to angle Y. Okay, let's start off, and we know that this line is equal to this line and is equal to this line. So seeing that these three lines in these triangles have same number of short lines on them, it shows that all of them are equal in size. So this angle is this line is equal to this line and is equal to this line. Now I'm going to use my pencil to fill up a lot of things. Now, seeing this part of the triangle, this triangle ABC, we could see that this side is also a base angle. So these are the equal sides, this is the unequal side, so this is the base angle. And base angles are equal. Therefore, this is 2x. And our reason for saying this is that they are base angles of an isosceles triangle. Okay. And then looking at this other triangle, angle ACD, triangle ACD, we could see that it's also an isosceles triangle because these two sides are equal. Therefore, this is the base. So as angle Y is at the base, this other place is also angle Y degrees. And then this remaining angle of this triangle ACD is equal to 180 minus 2x because they are angles on a straight line. So 180 minus 2x, 180 minus 2x is the size of this angle because they are angles on a straight line. Now, all these things I've already given the reasons for us doing this annotation inside this triangle. Okay, so let us just start writing our solution from here. Okay, so we are looking at angle. We have in triangle ACD, we have that 180 minus 2x, that is their vertical angle, plus angle y plus angle y are all equal to 180 degrees. And our reason for this is sum of angles in a triangle. In a triangle. So that's our reason for making this statement. Okay, so we are going to collect like terms. We have that minus 2x plus y, that's 2y, is equal to 180 that is on this side. This other 180 comes here to be minus 180 degrees. So 180 minus 180 is 0. So we have that minus 2x plus 2y is equal to 0. So all we have to do is to send this negative value over to this other side. That's like saying add 2x to both sides. So we have that 2y is equal to 2x. So we divide both sides by 2, right? Divide both sides by 2. And when we do that, we can see that y is now equal to x, or x is equal to y as we've been told to prove. We have that x is equal to y. Therefore, x is equal to y. So we started with our proof. Okay, but formally we should just have that given is this diagram. Then prove that x is equal to y. We don't have any construction to make, so this is our proof already that angle ACB is 2x. Reason base angles of an isosceles triangle. Angle CAD is y. Base angle of an isosceles triangle. Angle ACD is 180 minus 2x. Reason being angles on a straight line. That is all. We just say that 2x plus angle ACD is equal to 180 degrees. Reason angles on a straight line. Then we now make angle ACD the subject of that equation to have that it is equal to 180 minus 2x. So having that, we now continue with these lines. Okay.